Hello and welcome to Quadratics 3.2 Factoring Trinomials. Okay, so this section is going to be super long. Okay, I think this section alone I'm going to do 24 problems so that you guys get a good set of examples to work from, and hopefully I give you enough examples where yeah, you know exactly what to do when it's time for you to do your homework. So let's start. Okay, so this first technique is going to be called GCF, greatest common factor. Okay, so basically what we're doing is we're doing what is called factoring, which is breaking it up into tinier pieces so that when we put them back all together again, we make what we originally had. Okay, so back in your other math classes that you had lessons for, you did something called factor pairs, yeah, or factor tree rather, and that's kind of like what we're going to be doing now, except it's going to be something a little more complex. So I'll just give you a quick example of what the kind of factoring we're going to do here is, yeah, with a comparison to something you did back in other math classes back in the day. So let's say we had like the number 20. Okay, and in the past you would do factor tree, you would write 2 times 10, then you break apart 10, you go 2 times 5. So 20 is known as 2 times 2 times 5. So that's called factoring the 20, breaking it up into smaller pieces that if I multiply them back all together again, we get our original number. Okay, so this was a simplified version of factoring back when you guys had other math classes. Okay, so when you start getting to higher math classes like you are now, Algebra 2, okay, it's going to be kind of the same concept, except we're going to incorporate letters into the mix. So that's where it's going to make things a little more complicated. Okay, so this first technique we're going to do is called GCF factoring, and it's going to basically be, I like to call it reverse distribution, because we're going to, instead of giving something to everything in the parentheses, we're going to take away what both of them have in common and put that one thing that they have in common outside the parentheses. So when we do factoring, we're going to just right away, GCF factoring actually, when we do GCF factoring right away, we're just going to put a blank parentheses and we're going to ask ourselves, what can 10 and 15 commonly divide by? And you're going to say, oh, they can commonly divide by 5. Yeah, so 5 basically divides into 10 nicely, and 5 divides into 15 nicely. Okay, so that's the GCF, the biggest number that can divide into 10 and 15. Okay, and same thing goes for x squared and x. What is the amount of x's that when I take them away from 10x squared and 15x, what is the most I can take away from either of them? Yeah, so you can say, oh, I can take away x squared from both of them. No, you can't. Yeah, 10x squared, you can take away x squared from him because he has 2 x's to give. But 15x, does that guy have 2 x's to give? No. So you got to take away the most that either one of them can give you. So this guy only has a single x, right? 15x, he only has a single x, and that's the most either of them can give. Yeah? So when I take away the x from both of those terms, yeah, let's see what's left, and let's do what is called, what I like to call reverse distribution. Okay, so we got to figure out what two things are going to go in the parentheses that if I were to distribute, it would get 10x squared plus 15x. Okay, so first of all, yeah, 10 times what number makes, 5 times what number makes 10? So hopefully you say 2. And x times what makes x squared? And hopefully you say x. Okay, and same goes for the other guy. 5 times what number makes positive 15? Hopefully you say positive 3. And x times what makes x? Well, pretty much, yeah, it's already x, so you don't need to put anything next to the 3. It's just going to be a 3. Okay, and you're done. This problem is finished. Yeah, so I like to call it, like I said, reverse distribution. The book likes to call it GCF factoring. Okay, all right, so let's move on to letter B. So same thing, we're going to make blank parentheses right off the bat, and we're going to try to figure out what number can we put outside. Yeah, what number and what letter can we put out the outside? So what divides into 8 and 28 nicely? Okay, and hopefully you say 4. And if you did, that's very good. 2 works also, but that's not the biggest number possible. Okay, and what is the most amount of x's either term can give without running out? Yeah, so I can't give x squared because, yeah, he has enough x squareds to give. He has enough x's to give, but this guy doesn't have enough x's to give. So what is the most either term can give you without running out? And so that would just be a single x. Yeah, because if this guy gives up a single x, he can do it. He has 2. He has enough to spare. This guy can give out a single x because, yeah, he has a single x. He cannot give out more than that. That's why we cannot put x squared here because he can only give away 1. Yeah, so the type of question that you have to say to yourself as you're figuring out the 4 and the x, you just got to remember what to ask yourself. Yeah, what number divides into 8 and 28 nicely, and what is the most x's either of these things can give away before running out. Yeah, and if you think of it that way, then doing this reverse distribution, GCF factoring, it might get a little bit easier. Okay, but it just takes practice. Okay, so now let's figure out what goes in the parentheses. So 4 times what makes 8? And hopefully you say 2. And x times what makes x squared? So hopefully you say x. Okay, and 4 times what makes negative 28? Hopefully you say negative 7. And x times what is x? Oh, well, we already got that, so we don't need to put anything next to the 7. Okay, so letter B is done. Okay, so like I said in previous videos, if it seems like I'm going fast, just stop and rewind. Yeah. Okay, letter C. So now we have 3 things to figure out what they all have in common. So we're still going to start off the same way, blank parentheses, but now we've got to figure out what number divides into all 3, and if there's a letter they all can give. So first of all, we know we can divide by 2, so I'll put a 2 on the outside. Okay, and we'll ask the same question, what is the most amount of x's any of these 3 things can give? So this guy can give 2, this guy can give only 1, this guy can't give any at all. So like I said, right, what you're going to put on the outside here, right next to this 2, is the amount of letters, yeah, that represents the most anybody can give. So he can at most give away none, so therefore I'm not going to put an x on the outside because he can't afford to give away any x's because he doesn't have any. So therefore there's no x on the outside. Okay, so we're not going to have a letter on the outside like the previous problem, we're just going to have a number. So let's just ask ourselves 2 times what makes 2? You can put a 1. You don't have to put the 1 if you don't want to. And then since we don't have a letter, we're just going to put x squared. Okay. And 2 times what number makes negative 10? Hopefully you say negative 5. And since there's no letter here, we're just going to drop an x right next to negative 5. Okay, and 2 times what makes negative 18? So hopefully you say negative 9. And that one is done. So you can either leave the x squared there, or you can just put it as 1x squared. X squared, 1x squared, same thing. Doesn't matter to me. Okay, but most people are just going to put x squared. Yeah, the 1 might throw you off when we get to harder stuff later on. So yeah, I would recommend just leaving it as x squared in the future, but if you put 1x squared, I'm not going to mark that wrong. Okay, so let's go to letter D. So once again, blank parentheses. You guys see the pattern? Start off with blank parentheses each time. Okay, and then ask yourself what number divides into 3, negative 12, and negative 21. So hopefully you say 3. Okay, and what is the most amount of x's anybody can give away without running out? He can give away 2 before he runs out. He can give away 1 before he runs out. He can't give away any before running out. So I'm not going to put an x on the outside because he ran out before even giving away a single x. So therefore there's no x on the outside. Okay, so 3 times what makes 3? A 1. So I'm not going to write the 1 because you don't have to, so you just write x squared. And 3 times what makes negative 12? So you hopefully say negative 4, and just drop the x right next to it. And 3 times what makes negative 21? So hopefully you say negative 7. Okay, all right, letter D is all done. So I think the next problem is going to be a different technique. I'm just going to call it regular factoring. They're not going to call it regular factoring in the book or the handout, but I just like to call it regular factoring because it's the most common one that we use in most math classes. Okay, so the trick to this factoring technique is you got to do kind of like a math puzzle. Okay, so here's what the math puzzle is going to be, just like it's going to be a series of 2 questions. Okay, so what 2 numbers multiply to make positive 12 and add to make negative 7? Okay, so you got to find 2 sets of numbers that multiply to make 12, and those exact same 2 numbers that multiply to make 12 add to make negative 7. Okay, so if you know your multiplication of 12 really well, you're going to go 1 times 12. Does that multiply to make 12? Yeah, but does it add to make negative 7? No, it adds to make 13. So that's not the number I want. Okay, what about 2 and 6? 2 and 6 multiplies to make 12. Yeah, that's good. But 2 and 6 add to make 8. So I don't want that. Okay, so I forgot this first step. First, you want to make blank parentheses. So like in the previous factoring problems, I always started off making blank parentheses. So this guy, regular factoring, is going to get 2 sets of blank parentheses. Okay, And the thing that you're gonna also want to do before I start asking the question, I kind of went in the wrong order, sorry about that, is the placement of things in the two parentheses correspond to the original problem. Okay, so since you have x squared in the front of your original problem, you're going to want to put whatever makes x squared in the front of each of these parentheses. So x squared is the result of x times x. So we're going to go x in the front, x in the front. And like I said, we put them in the front because x squared is in the front. Okay, and the two numbers that make 12 when you multiply are going to go in this space in the back. Okay, and that's where I started rambling off numbers like 1 times 12, 2 times 6, right? And 2 times 6 didn't work because that makes 8. So is there any other pair of numbers that make 12? And you're going to say, oh yeah, I think so. I think 4 and 3 make 12. Yeah, so 4 and 3, they make 12 when they multiply. Does 4 and 3 make 7 when you add? Yeah, it does. It makes positive 7. But we don't want positive 7. We want negative 7. So here's what you do. You just change 4 and 3 into negative 4 and negative 3, and your puzzle has been solved, right? Negative 4 times negative 3, that's positive 12. Negative 4 plus negative 3, that's negative 7. So this problem is done. Okay. So the thing about factoring, yeah, is most of the work that you do to get the answers are going to be in your head. Okay, so that can both be frustrating and easy at the same time. Okay, and because you're going to do most of your work in your head, yeah, you're just going to pretty much go straight from original problem to answer. Okay, so yeah, let's just try it out again. So first thing for letter B, we're going to just make blank parentheses, 2 sets. Yeah, not one set of blank parentheses like the previous factoring technique. We're going to make 2 sets. And like I said earlier, whatever goes in the front is in charge of making x squared. So we're going to put x and x in the front because x times x makes x squared. Okay, and what two numbers make negative 35 when I multiply? So multiply to make negative 35. Oops, not multiply. And add to make negative 2. So here's the tricky part. Okay, we got negative 35. So to make a negative number, one of the two numbers that you multiply has to be positive. One of the two numbers that you have to multiply has to be negative. Okay, so if you can just ramble off the factor pairs of 35, like 1 times 35, 5 times 7. Okay, that's not that bad because there's only 2 sets of numbers that make 35. So 1 and 35, 5 and 7. So 1 and 35 is not going to work. Yeah, because when you try to add a negative and positive version of 1 and 35, you're going to get like positive 34 or negative 34 when you try to add up 35 and negative 1 or negative 35 and positive 1. So that's not going to work. So it must be some kind of 5 and a 7. So I'm just going to write down 5 and 7. And we can figure out the signs right now. Okay, so we need to have negative 2 when I add them up. So what's the only way I have negative 2 when I combine 5 and 7 together and add them up? Well, I got to get a negative 7 and I have to have a positive 5, right? Because positive 5 minus 7, when I add them up, that makes negative 2. So that works. And positive 5 times negative 7, that makes your negative 35. Okay, so the hard part about this, yeah, is you really got to know mental math. Yeah, so that you can play with the numbers in your head. Because, like I said, a lot of this stuff is not on paper. A lot of this stuff is in your head. Yeah, and that's a huge reason why when I teach my math classes, I don't want my students using a calculator because if you use a calculator, your brain is not exercising. Your brain is not getting stronger. Yeah, the calculator is doing all the work. Yeah, and if the calculator is doing all the work and you're not doing any of the work at all, then your brain is not exercising. And when you got to do all this mental math, it ain't gonna happen. Yeah, so you really, hopefully didn't use your calculator the first couple of weeks before we arrived at this lesson, because if you did, then your brain is probably even more worn out than it was before because, yeah, it hasn't been doing any exercise at all. Okay, so you got to condition your brain so that it can think in your head rather. Okay, all right, so let's look at C. So same thing, 2 blank parentheses, and then we're going to put x's in the front because they're in charge of making x squared. Okay, so whatever's in the front, yeah, the front parts of each parentheses, they make the front term of your problem. Okay, then the 2 numbers in the back, they're going to be in charge of making negative 24 when I multiply and positive 5 when I add. Okay, so we can do 1 and 24. No, that's not going to work, right? Because that makes like 23. Yeah, because it's negative 24. So one guy's going to be positive, one guy's going to be negative. So they're going to decrease when I combine them together. Yeah, so 1 and 24, that makes 23. That's not going to work. 2 and 12, that's going to make 10. Okay, and you're thinking 10, how does it make 10? 2 and 12 make 14. No, we're not. We've got to remember this is a negative 24. So one is going to be a negative number, one is going to be a positive. So in essence, when I combine them, when I add them, they're going to be subtracting. Yeah, so 2 and 12 make 10. 10 or positive 10 or negative 10. Okay, so that's not going to work. So what about 3 and 8? Ooh, yeah, 3 and 8. I think that makes 5. So I write 3 and 8, and then I want to make sure I have a positive 5, so I put positive 8, and I put negative 3, and let's check it out. Right? Negative 3 plus 8, yeah, that's positive 5. Negative 3 times 8, yep, that's negative 24. It works. Okay, so like I said, you got to just know your numbers. Okay, that's the whole trick to factoring. You got to know your numbers and how to just do math in your head. That's the easiest thing. That's the best thing you can do to get good at factoring. Just multiply and add numbers, random numbers, as much as you can. Okay. Okay, letter D. So blank parentheses again. I'm going to put x's in the front because they're in charge of making the x squared. That's in the front also. Okay, so now I got negative 18. And it's a negative again, so you got to have one guy positive, one guy negative. So if I go 1 and 18, that's going to make 17. Yeah? And if you're still getting confused how 1 and 18 make 17, you got to remember, it's negative 18. So one of my two numbers is going to be positive, one of my two numbers is going to be negative. Yeah, so when I have 1 and 18, they're going to actually decrease in size, or you're going to kind of like subtract it, so you're going to get 17. And that's not my middle number. My middle number is a 3. Okay, so what about, let's see, 2 and 9. 2 and 9 make 7. No, that's not going to work. What about 3 and 6? Yeah, 3 and 6 makes a 3. But I just got to play around with the signs. Okay, so I got a negative 3 in the middle. So I'll put negative 6 and positive 3. So let's check it out. So positive 3 minus 6. Does that make negative 3? Yep, it does. When I add them up, it does make negative 3. Positive 3 times negative 6. Does that make negative 18? Yep, it sure does. Okay, problem is done. Okay, let's try the next one, letter E. So now we're gonna, same thing, you're gonna see me doing the exact same first step, blank parentheses. Okay, so get into that habit, just put the blank parentheses first, lay out your foundation first. Okay, and you're gonna put x's in the front because they're in charge of making x squared. Okay, so what two numbers make 40 when you multiply and positive 6 when you add? So once again, it's a negative 40. So when I combine my numbers, we're gonna kind of like subtract them. Yeah, because it's one is positive, one is negative. So if I go 1 and 40, that's 39. If I go 2 and 20, that's 18. If I go 4 and 10, ooh, yeah, that's a 6. So let's do 4 and 10. Okay, so one guy has to be positive, one guy has to be negative. So we're dealing with a positive 6, so I'm going to make positive 10, negative 4. Yeah, so that when I go negative 4 plus 10, I get positive 6. When I go negative 4 times 10, I get negative 40, and there it goes. Okay, so this next problem is going to be almost your worst nightmare up to this point so far. So we're going to do two techniques on one problem, on this next problem. Okay, so first we're going to do GCF, and then we're going to do the kind of factoring that we just did just now. Okay, so first we're going to say, okay, we have a 5, we have a 45, and we have a 90. So is there anything I can GCF, yeah, reverse distribute from all three of these things? And you're going to hopefully say I can take away 5 from everybody. I cannot take away x because 90 doesn't have any x's to give, but I can at least take away a 5 from everybody. So when I take away the 5, I get x squared plus 9x plus 10. Okay, and this problem is not done yet, right? Or is it done? Oh, what am I doing? Why did I write 10? Okay, sorry, I'm dreaming. Yeah, it's like 11:35 at night when I'm making this video, so yeah, this is when the house is quiet. So I put the wrong number. I'm really sorry about that. It is not 10. Okay, I don't know what I was thinking. It's 14. Okay, so now we're gonna do regular factoring like we just did. So here's how the first step is gonna change. Yeah, I'm not just going to write blank parentheses like I did earlier in the previous couple of examples. I got to also write the 5 that's on the outside because that's part of my final answer, because that 5 was gained through the technique called GCF. So you got to make sure you transfer that 5 downwards in the steps. You still got your 2 blank parentheses, but you got to transfer that 5 from one step to the other. We're still going to put the x's in the front because that makes x squared. And we're going to find 2 numbers that multiply to make 14 and add to make 9. So hopefully you say 2 and 7. And if you did that, you're good to go. That's it. That's done. Okay. So this problem is going to get trickier because a lot of kids are going to be like, okay, I did factoring, I did GCF, so I'm done, right? No. Sometimes when you do GCF, you can still factor it one more level. And if you can factor it one more level, you are supposed to do it. It's not an option, it is a must do. Okay? All right. So let's try another GCF then factoring problem. So let's see, I make the blank single parentheses because I'm going to do GCF first, right? GCF requires single parentheses. I take out a 3 because everybody can divide by 3. Do I take out an x? No, because 60 doesn't have any x's to give. So what's left after I take away a 3? So I get x squared minus 12x plus 20. Okay, so now what numbers make, actually, no, before I ask that question, I'm just going to transfer down the next step. So 3 and 2 blank parentheses, and then x in the front, x in the front. So I'm gonna go in the same order I've been going along so far. Okay, so what two numbers make 20 when I multiply and 12 when I add, or negative 12 when I add, rather? Okay, so notice how this is not a negative 20. So when I get my two numbers, like 1 and 20, I'm going to get 21 because it's a positive 20. So none of them have to be a negative. Right? Remember how when it was a negative, one guy's positive, one guy's negative? So the numbers, when I add them up, they decrease. Because this is a positive 20, when I add up the numbers, my number that I add is going to get bigger. So 1 and 20 is 21. 2 and 10 is, 2 and 10. There we go. 2 and 10 is 12. Okay, but the thing that I got to remember is this is a negative 12. So I got to go negative 2 and negative 10. Yeah, because negative 2 plus negative 10 is negative 12. Negative 2 times negative 10 is positive 20. Okay, so sometimes it says positive 20 and you're going to get negative numbers that multiply to make him, but you got to make sure you have both of them negative. Okay, so you just got to get practice. The only way to get good at factoring is you just got to practice. You got to condition your brain to do math in your head, and you just got to practice as much as you can. Okay, so let's do H. So same way I started off, the 2 in the front because that's what everybody can divide by, blank parentheses. So I get x squared plus 7x plus 10. Okay, then I write my next step, 2 with 2 sets of blank parentheses and x is in the front. So what numbers make 10 when I multiply and 7 when I add? So hopefully you say 2 and 5. And in this case, positive 2, positive 5. Okay, all right, moving on. Like I said, if I go too fast, just stop, rewind, do what you got to do. Yeah, but I'm just going to keep on chugging along. Okay, so this next set of problems, this is the hardest factoring technique that you're going to see today. Guess and check factoring. So the reason why I call it guess and check factoring is you can't lock in on the correct answer on your first try usually. Okay, you gotta just guess and see if you're correct, and if you're wrong, just do it again. Okay, so I know what the answers are because yeah, I did these problems beforehand. So I'm gonna guess wrong on the first try. Yeah, but you're gonna see me doing the same couple of setup steps. I'm gonna still do 2 sets of blank parentheses, and I'm gonna put the numbers in the front that are in charge of making 2x squared. So what numbers make 2x squared? Well, 2x and x make 2x squared. Okay, and like I said, I'm going to guess wrong on the first try to getting the numbers for 21 and negative 17. Okay, so I'm just going to put 7 and 3. Okay, so it's a positive 21, so I got to put numbers that make positive 21 when I multiply, so I've got to keep that in mind. And when things combine, I got to have a negative 17. So I might have to put negative 7 and negative 3 because, keep in mind, yeah, I got to get negative 17. Okay, so here's how you check your answer. So this is my guess. Now I got to check to see if I was on the right track. So I'm going to do kind of like foiling, but I'm not going to do the complete foiling process. I'm going to just do the inside-outside part of foiling. Okay, so when I multiply my insides, that's going to be negative 7x. When I multiply my outsides, that's going to be negative 6x. And when these guys combine together, they make negative 13x. Is that the number in the middle that I wanted? No, I wanted negative 17. I got negative 13, so this answer doesn't work. So back to the drawing board. So let's try one more shot. Okay. So for me, I think 3 and 7, that's the right numbers to pick. So I'm going to keep with that set of numbers. I'll make my blank parentheses again. I put the numbers in the front that are in charge of making 2x squared, so I put 2x and x. And I'm pretty sure 3 and 7 are going to work. So let's just change the location of the two numbers. So it makes a difference. Yeah, 3 was in the other parentheses in the previous trial. 7 was in the first parentheses in the previous trial. So you're thinking, why is that going to make a difference? I'm using the same numbers. Yeah, you are, but you're pairing it up with different insides and outsides. Okay, so I'm going to keep 3 negative, going to keep 7 negative also, and I'm going to do inside outside. So I get negative 3x, I get negative 14x, and when I combine together, I get negative 17x. So I got it, right? 2x times x, that's 2x squared. That's my number in the front. Negative 3 times negative 7, that's positive 21 in the back. And my inside outside, negative 3x, negative 14x, that's negative 17. That's my middle. So here's my final answer right there. Okay, so that's why I call it guess and check. We tried our first option, it didn't work. We tried a second option, we checked our answer, it worked. Okay, so that's why I call this guess and check. You're not going to usually find the right response on the first try. Okay, so let's try another problem. Let's try letter B. So same thing like usual, blank parentheses to start off with, 2 of them. Then you're going to put in the front whatever is in charge of making 2x squared. So that's easy. That's 2x and x. Okay, so now we're going to try to figure out what numbers can we use for negative 20 when I multiply and negative 3 when I combine everything up. Okay, so let's see. Let's try some kind of 2 and a 10. So let's try 10 and 2 to see if that works. And it's a negative 20, so one guy has to be positive, one guy has to be negative. So maybe make this guy negative, that guy positive. Let's see if it works. So yeah, 2x and x, that's 2x squared, that's good. Negative 10, positive 2, that's negative 20, that's good. So I'm on the right track so far. I got my first number, I got my last number. Do I have my middle? Well, let's do the inside-outside. Inside-outside is always in charge of making your middle. Okay, so inside is negative 10x, outside is positive 4x. So when I combine it together, I get negative 6x. So did that work? No, I don't want negative 6x. What number do I want? I want negative 3x. So we're back to the drawing board again. So blank parentheses, and we're going to put 2x and x. Okay, so maybe 2 and 10 are not the numbers I want. Maybe it's 5 and 4. So let's try that out. So 5 and 4. And I want a negative 20, so I got to give somebody negative, somebody positive. So I'll just try to give this guy positive, this guy negative. Okay, and let's just see if it works. So 2x times x, yep, that's 2x squared. That's my front. Positive 5, negative 4, yep, that's negative 20. That's my back. So notice how the placement of all of these numbers, they make all 3 of these numbers from my original problem, right? The 2 fronts make the front. The 2 numbers in the back of the parentheses make the back number. And my inside-outside, they make my middle. Okay, so my inside, outside, let's see what they do. So inside is going to be positive 5x. Outside is going to be negative 8x. And when they join forces, they make negative 3x. Is that my middle? It sure is. There's my winning combination right there. Okay, this is the most frustrating technique to factor because you can't lock in on the correct answer on the first try. I mean, you can if you get lucky, but it's not going to happen very often. Okay, so yeah, you're going to get fast at multiplying, you're going to get fast at adding because the more times you check, the better you get actually. So the kids that actually get really good are the ones that actually make a lot of mistakes and guess wrong a lot because they're practicing this checking step so many more times than anybody else. Okay, so that's the kind of ironic thing. Yeah, to get really good at guess and check factoring, you got to get a lot of guesses wrong because the more times you check, the faster you get. Yeah, so that's kind of ironic how that works. Okay, so let's try the next problem, letter C. So same first step, we're still going to do blank parentheses, okay? We're still going to put the 2 numbers in the front that are in charge of making the front term, so that's 3x squared, so we're going to put 3x and x. Okay, and now we're going to find 2 numbers that make 10, okay? And since you kind of get the hang of what's going on, I'm not gonna guess wrong anymore. I'm just gonna lock in on the right combination of numbers. Yeah, and I got these numbers because I did the answers already beforehand, before I made this video, so I know which ones work. So I did my guessing and checking already. Okay, so if you're thinking, oh, Ishikawa's getting it correct on the first try, yeah, of course I am because I did it already on a scratch piece of paper. Okay, so I'm going to put negative 5, negative 2 because I need to make positive 10, and my middle number is negative 11. Okay, so the 2 fronts, you got to make 3x squared. 2 backs, negative 5, negative 2, yeah, that's positive 10. My inside, outside, let's see if that makes negative 11x. So inside, outside, I get negative 5x, I get negative 6x, and when they join forces, they make negative 11x. So there we go, that's our winning combination. Okay, Letter D. So blank parentheses, 5x squared in the front, so I'm going to go 5x and x. Okay. So when the front number gets tricky, we're going to put like 6x squared or 8x squared, because then you're going to have multiple ways of getting that first number. It's not just going to be 5x times x or 3x times x. It's going to be a couple of different options, and that's where it's going to get really tricky later on. Okay, so let's see. The winning combination is going to be -4 and +3. Okay, so 5x times x, yep, that's 5x squared. -4 times +3, yep, that's -12. And my inside-outside, does that make +11x? Well, like I said, I did these problems already. I know it's going to work. Yeah, but please, 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 as you're watching these videos, don't think you're going to guess correctly on the first try. Yeah, it didn't take me one try to get all these answers. I had to guess multiple times. Yeah, sometimes I got it correct in the first try. Most times I did not get it correct in the first try. Okay, so you're just seeing the result of me doing the guessing already before I make this video, because I don't want this video to go on for an hour. Yeah, so I'm going to kind of speed it up as far as these problems are concerned. Okay, letter E. So, still same route, 2 blank parentheses. Okay, but this is where it's going to get tricky, because there's multiple ways of making 4x squared. You can do 4x times x. You can do 2x times 2x. Okay, and that's where you're going to start really hating these problems, because you're not just going to play around with the back number of 15 with 3 and 5 and 1 and 15. You got to play around with the front number also, 2x, 2x, or 4x and x. Yeah, and like I said, I know the answer because I guessed many times on this problem. I thought it was 2x, 2x for a long time. And then I realized, oh darn, it's not 2x, 2x, it's 4x and x. Yeah, so I was trying the wrong combination with that front number. But that's why we call it guess and check, right? Okay, so we're going to do +3 and +5. So 4x times x, yep, that's 4x squared. 3 times 5, right, +3 times +5, that's +15, that's good. And in my inside-outside, let's see if that makes +23. So I get 3x and I get 20x. And when they join forces, they make 23x. So that's good to go. Okay, we got our combination that works. Okay, so let's go on to letter F. So once again, you're seeing the same thing, right? Blank parentheses. Okay, this is where it gets tricky though. There's multiple ways of making 10x squared. We can go 1x, 10x, or we can go 2x, 5x. Okay, so this particular problem is going to be 2x, 5x. It's not going to be 1x, 10x. Okay, I made mistakes already, like I said. I went through all the guessing and checking already. Okay, and this is going to be -3 and +6. Okay, so let's see if it makes the numbers, right? 2x, 5x, yep, 10x squared. -3, +6, yep, that's -18. Okay, and then let's do inside, outside. So inside is going to be -15x. Outside is going to be +12x, and when they join forces, they make -3x. So it works. Yeah, not a surprise, because like I said many times already, I did these problems before the video was made. Okay, so it just looks like I'm guessing correctly on the first try each time. I'm really not. I guessed many times before I got to the right answer. So please don't sweat it if you can't get it on the first try. Just keep on trying. Okay. Okay, last technique for the day. Okay, you're going to do difference of two squares. And this technique takes advantage of the fact of knowing what are called perfect squares. So when I say perfect squares, I mean like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. Right? Those are what we call perfect squares. Okay? So if you see a problem that is basically comprised or made up of perfect squares, then you're probably seeing this pattern. So x squared is a perfect square because that's x times x. 64 is a perfect square because that's 8 times 8. Yeah? And if you see a negative sign in between the two perfect squares, you can run this pattern. So watch how this pattern works. It's going to start off the same as the previous technique. We're going to start off with blank parentheses. So that's no different. We're going to put the two numbers in the front that make x squared, so x and x. And we're going to put the two numbers that make 64 in the back, except we're going to use the perfect squares for our numbers in the blanks, so 8 and 8. And since it's a -64, we're going to put one guy positive, one guy negative, and we're done. Okay, so this is the pattern called difference of two squares, where we pick up the fact, we notice the fact that x squared and 64 are perfect squares. So we just write the exact same contents of each parentheses in each parentheses, and we just put one guy positive, one guy negative, and we're done. So let's move on to letter B. So blank parentheses once again. Okay, and is 9 a perfect square? Yeah, that's 3 times 3. Is x squared a perfect square? Yeah, that's x times x. Is 16 a perfect square? Yes, that's 4 times 4. So everybody's a perfect square, and they have negative sign in the middle. So this is that pattern that you can use, difference of two squares. Okay, so once you see that pattern, right, everybody's a perfect square, negative sign in between them, you can run this pattern. Okay, so what do I put in the front? I put 3x, 3x. I put the numbers that are my perfect squares to make up 9x squared in the fronts. And then I put the numbers that make 16 in the back because 16 is in the back. But since it's a negative 16, I go one guy positive, one guy negative, and we're done. Okay, so once you run the pattern, you're good to go. Okay, all right, let's look at letter C. Okay, 49, yep, that's a perfect square, 7 times 7. X squared, yep, that's a perfect square, x times x. 25, yep, that's a perfect square, 5 times 5. And we have a minus sign in between them, so we're good to go. What if we ever have a negative sign in between these things? Yeah, what if it was 49x squared plus 25? Can we do difference of two squares? No, we can't. Okay, it has to be a minus sign in the middle. All right, so we're going to put 7x, because that's my perfect squares that made 49x squared. We're going to put 5 and 5 in the back because that's what makes 25. And because it's negative 25, we're going to put positive negative. And here's where I get the question. What if I put negative in the front and positive in the back? Is that still correct? Yeah, that's still correct. You can put negative 5 in the front. You can put positive 5 in the back. That's you're good to go. Just make sure they're different signs. You can't put negative 5, negative 5. You can't put positive 5, positive 5. It has to be opposite signs in this pattern. Okay? All right, next one. And here's where you say, ooh, 20 is not a perfect square. 5 is also not a perfect square. But then you take a little look at the hint up top. It says difference of two squares, right? That's the theme of this particular problem, because we're going to practice that technique in this set of problems. But we're going to do GCF first, then difference second. So what number goes into both 5x squared and negative 20? So since we're doing GCF, we make a single parentheses. We put a 5 on the outside because that's what divides into 5 and 20. Am I going to put an x on the outside? No, because negative 20 doesn't have any x's to give. So I don't put any letters outside there at all. So when I take away the 5 from both of these guys, I get x squared and I get negative 4. Okay, so is x squared a perfect square? Yeah, x times x. Is 4 a perfect square? Yeah, 2 times 2. So watch what I do next. I drop down the 5. I make 2 sets of blank parentheses. You've seen this before. The only thing that's different is I put a 5 on the bottom. Put an x and put an x, yeah, in the front. Put a 2 and a 2 in the back. Make it opposite signs, and boom, you're done. Okay, so GCF first, then difference of two squares. Okay, next one. Okay, so GCF first, once again, so 18 and 8, I can take away a 2 from both of those, yeah? So single parentheses, right? Put a 2 on the outside. Do I put letters on the outside? No, because negative 8 doesn't have any letters to give, right? So you can only put a letter on the outside, yeah? That is as much as this guy can give. So if this guy cannot give any, you don't put any x's on the outside. This guy can give 2, but we don't look at him. We look at who can give, what's the most anybody can give. And this guy can't give any, so therefore I don't put any x's on the outside. But they both can divide by 2. Okay, so I get 9x squared, and I get negative 4. Yeah, 9x squared, yep, that's a perfect square. 9 is 3 times 3, x squared is x times x. And the 4 is 2 times 2. And we got a minus sign in the middle, so we're good to go. We got all the signs of difference of two squares being good to go. So the 2 on the outside, blank parentheses, we put 3x and 3x in the front. We put 2 and 2 in the back. We put opposite signs, and we're done. Okay? All right, letter F. So GCF, so I put single parentheses. What number divides into 32 and 18? I think that's a 2. Do I put any letters on the outside? No, because negative 18 doesn't have any letters to give, so I don't put any letters on the outside. So what's left after I take away a 2? So I get 16x squared, and I get negative 9. So next step, difference of two squares, right? Because 16 is 4 and 4. X squared is x and x. 9 is 3 and 3. So we got all the makings of difference of two squares. And we got the minus sign in the middle also. So that's the ice, that's the topping on the cake, right? So 4x in the front, 4x in the front, and 3 and 3 in the back. Notice how when I put these numbers in the parentheses, they're all perfect squares, right? 16 is 4, x squared is x, 9 is 3. So I'm putting in the perfect squares in these spots. Yeah, so like I said, if you can see this pattern, it makes your life so much easier when you're trying to factor. Okay? All right, so I believe that is the last problem. So good luck. I think your homework assignment tonight has 18 problems. So lots of problems, way more than usual, but like I said, to get good at this, you gotta practice. Okay, so I'll see you in class, and yeah, good luck. Bye-bye.